Hi Mark, I'm just sharing this stream to the group. Okay, now we'll start. So I started streaming and it was set on private, so I was wondering why I was staying at 0 people watching. So this should be okay. I don't know what res it is, but it looks fine. I'm going to get this out of the way. And let's go ahead and start. So we have an 820-3476. We get no backlight on the screen. The customer has tried with a new screen. We're going to go ahead and dry it up for now. Back to I've been swamped with MacBooks. It's good. So we're gonna go ahead and just give the board a look over, right? Can't really see any liquid damage. Just gonna give a look over. This isn't liquid right here. This is just nastiness. It's not anything to be concerned about. Under the BIOS, that's Flux. That's not liquid. SMC area, that's not corrosion or anything right there, just yuck. Our backlight driver area. This is a very common problem. Pin 5 of this chip right here will fry, and as you can see, that looks perfectly fine. There is no sign of any form of damage under that. So let's flip this over. Let's go over this side where backlight is. See our backlight diode, right? That doesn't look like too happy. That looks like it might have got some liquid, but that's not a problem. So see, tweezers. This cap right here, that got some liquid, very minor. I wonder why we have no backlight. Yeah, that got burned. And it looks like I lost the stream. Did I lose the stream? Nope, I'm still up. Yeah. Very obvious burn damage to the pins on this. Okay, this is what happens on MacBooks, okay? Instead of the fuse blowing, okay, for backlight, this is what you get. You get the connector and the board blowing instead of a fuse. So this is what happens when water hits the backlight circuit. Okay, so now we're going to talk a little bit about voltages. What the different voltages mean on backlight output. In order to test backlight output, you need a screen connected. You can't have no screen plugged in. The LCD won't be recognized and it won't get the signal from the PCH to enable backlight. 8 volts means the backlight driver is not boosting. Replace the LP8550 and you're probably going to notice pin 5 is going to be gone, corroded. You're going to need to run a wire to pin 5 of the LP8550. That's another common issue. 18 volts, it's partially boosting. Again, same problem. LP8550 and pin 5. 25 to 27 volts means it's working properly. 39 to 50 volts, it means there's no load on it, bad connector, bad LCD cable, blown fuse, or a bad screen. Most likely I've seen is a bad screen when you have no load on it. So anything 39 and above, you usually have no load, bad connector, bad cable, or bad screen. Very rarely a bad fuse. But these issues are pretty easy to diagnose. Usually they're very obvious. If you have 8 to 18 volts, you're almost always going to notice the backlight driver being corroded and pin 5 being burned. So let's go ahead and start. Let's take off this connector because obviously this needs to go. Get my quick 430 degrees at 100% air. We are going to rip this off the board. Otherwise, this does not look too bad. It just got burned. I don't see anything else that's needs attention on this, so this should be a nice, quick repair. was the first connector coming apart like that. This never happens. So as you can see, we got the connector off. There is nothing left of this. Is burned really bad. There's nothing left of that. So now the thing is there a short internal of the board, also common. There could be a short, probably right in here. You can kind of see it into the board, and that's what caused that. And if we put a new connector on, it's probably going to short right away. So we're going to go diode mode on this line and see if we have a short. The measure, see this cap right here, one side is ground, and we have open lines. We have no short, but we have a massive hole. We're not going to worry about that. What we're going to do is get all this leaded solder out of here and start wicking these pads. Get a new connector on, and we're going to run a little jumper wire from this capacitor to these pins, and you will watch the screen will come on and work beautifully. Well, maybe not. It could have a bad backlight driver, but I doubt it. It's rare. Well, not rare, but usually this is a separate issue. The LVDS connector is just in a bad area where liquid always will hit it. Just in one of those spots where it's always going to get hit. Pretty much almost every air I see has corrosion on the LVDS connector. Sometimes it's not bad, sometimes you don't need to replace it. Oftentimes I just replace it just to be safe. Now the connectors cost what? They're cheap. And we might have another suspicious looking pad here. Right here. It's actually, if you look close, I don't know if you can see this, but the pad isn't actually bad, it just has stuff on top of it. See, that pad is fine. But what is it for? Let's double check on the board view. Might even be NC. What board is this? 3437. Where is that? And again, I don't know how many times I have to repeat myself. And this board is fine. I'm not referring to this board, just in general. This board I don't think was cleaned, and if it was, I could see the fault. But I've been seeing a lot lately that people have been saying, well, you know, I'm going to clean the board and I'm going to ultrasonic it. Please do not ultrasonic a board that has liquid damage without first addressing what's under the corrosion. You'll destroy it. It's been happening more and more where people just, you can't throw a board that has corrosion all over it straight into the ultrasonic. It's going to get destroyed. So diagnose, fix the issues under the one second here. Fix the issues under the corrosion before ultrasonicking. Ideally, do not ultrasonic anything until the repair is done. I don't. The only time I'll ultrasonic something before the repair is done is if, you know, it's quarter fan spinning, I suspect corrosion under the PCH or something. That's when I will ultrasonic something. But not, I won't just take a board that doesn't work and throw it in the ultrasonic to see if it fixes it. That is not the way to go, and it's just going to ruin a lot of your boards. Well, not ruin, but it's going to make an easy repair into a very difficult repair, because now I have to run wires under things, and you know, it's just not fun. Wrong video. Yeah, that's what I figured. I knew the chat was up. We're going to get a brand new connector. If I could find where I put my connectors, because I moved them. Right here. I have this connector in stock, the LVDS, or especially for the newer ones. You're going to need it a lot. Alright, so I'm sure pretty much everybody watching this knows how to solder this connector by now. It's pretty easy. Lines itself up. Has these little alignment spots in the board. Just like that. You want to get this as close as you can. You don't want it to be crooked or anything. So that's aligned. Now what I'm going to do is get a little flux, and I'm going to solder these posts, right? Now, you can go crazy on this one, put as much solder as you want, but this guy, be careful. So, and I'm pushing it so it lost alignment. So now I don't have any worry now that it's going to move around. Now I can go ahead and make that joint a little bit better because I like to make it look like factory. Don't be afraid to use a ton of flux on these. See, I probably screwed up right there. We'll find out. Let's have a look. I probably screwed that up. How you check is the microscope up. Let's have a look. No, that's fine. Okay, so now what we can do is go ahead and solder the rest of these. We're going to want to push it down because it's kind of sitting up just a hair. So I'm going to push it down. I'm going to get more flux and line it along these pins right here. Just get a ton of flux in there. Use as much as you want. We'll clean it after. Sometimes flux can make the screen act funny, but it's not all that common. I've seen it a couple times, but you just have to clean it when you're done. That's all. That one I definitely screwed up. I'm used to soldering them at this angle, that's why I kept screwing it up. So this was the angle I'm used to. Let me see, let me look at it again. Because I had the board at the wrong angle. Yeah, see, that's no good. No, it'll be alright. Should be okay. I always solder them this way, so that's why when I had the iron positioned a different way. There's a trick to these, so let's get a little solder in. Sometimes these can go on so nicely, and then other times they're just a pain and miserable. might think, oh well, you bridged it right there. Well, tell me why this should be bridged. See, right here? Not right here. Gonna move the bridge downstream to where you want it, right there. So see this? It's gonna make it easier for me to solder my wire right there. That's perfectly fine. You don't want any more bridges anywhere else, of course. I like to touch the pins up a little bit, just to make sure they're connected. If I see any that I have any doubts about, but those seem nice. So now we're gonna put a little solder on these ground pins. These ones I can never make look nice. They're always kind of unprofessional, if you will. Speaking of unprofessional, I have to show you guys some C7771 fixes I did today. Make a genius have a panic attack. Okay, so now, see, we don't even need to look at the schematic or anything. Have a nice big trace to run a wire to. The reason why I'm adding a little flux here is to touch that up. Get good solder on there. Let's get our little jumper wire. This is small. Obviously it's point something, 0.37 I think. No, what am I saying? It's 37 gauge, it's 0.10 millimeters. Get a little bit of this wire. We're going to run a jumper. And we're going to check if we don't get backlight output. We're going to measure voltage and determine what is wrong in the circuit. I need new tweezers. Not even funny. No. These seem better. So we're going to get our little jumper. And the way I like to do these, kind of loop them. You could do it however way you want, but I kind of like to do it like this. So it really doesn't matter. I just like to have them go in kind of straight. I've had people complain. I say, well, you need to use a shorter wire. What does it matter? I mean, what does a shorter wire have to do with anything? I don't care. If it works, if it conducts electricity in a way that the screen shows light on it, what does it matter, you know? There's our jumper. Let's clean that up a little bit. We're going to see if it works. Then this will get a little ultrasonic bath, and be back to the customer tomorrow probably. Came in at, I don't know, 5-ish today, and that's what I've been striving for, that 1-day turnaround time. And I'm fairly busy right now too. think this has been the busiest time since I started, which is good. It's picking up, and it's not, you know, it's getting better and better as time goes on. We have our jumper. No bridges on the connector that I can see. Storming strong now, gotta shut down. No problem. Thank you for watching. Where is the enclosure? Yeah, I can't wait for my quad-core desktop to come. Dual core is getting kind of old. And I need something a little bit quicker. Also trying Seagate's SSHD drives. See how they are. I mean, I don't want to spend money on a 1 terabyte SSD when I can get a, you know, I don't really care too much about startup speed. But the Seagate drives are apparently decent, so. I've had one Seagate, had like 3,000 hours on it, and it started getting bad sectors. Connector's a little tight, but it'll be okay. And then Stellar Cellular, Richard. Good angle for the camera, thanks. So remember that little bit of solder that I kind of got it spilled into the connector? It's going in really tight, but I don't see it being a problem. Let's see if the screen works. Fan is spinning. And it's going to do an RTC reset. What an RTC reset is, it's going to spin, stop, spin, stop, spin, stop like 4 times. Then it'll finally start, and we should get a light image on the screen. And as you can see, well, that is a backlit screen. Let's wait till it gets image so we make sure we didn't screw anything else up. But we should get a flashing question mark very shortly. It's hard to see. That was the charger falling out. Let's shut off the lights. Maybe then I'll be able to see the light on the screen when it comes on. Remember there was that one person that in my chat that just thought I broke stuff before streaming and then fixed it, so I knew what I broke, or that I just made it appear that I fixed stuff and never actually tested anything because I didn't put the board in the enclosure. But you can see the backlight. Let's wait till we get an image, a flashing question mark. But I know we will. Well, I don't, but maybe no image. Nope, there we go. Flashing question mark. So this is fixed. This is going to get an ultrasonic. And now let's take a look at, you should be at mod. Your messages should not be getting hidden. I don't know, I have a pretty good luck tonight. Let's try a quarter fan spin. 6 people are watching, we have 10 viewers. Let's see me versus quarter fan spin. Okay, so this is the next one. This is an 820-2936. that has been ultrasonically cleaned before getting here, effectively washing away all my clues that I could have used to fix this. So, if we look at the microscope view, we have quarter fan spin. And this is going to suck because there's no clues here. I already replaced, my first clue was that my first clue is that the V-core was not pulsing, so that made me think, well, maybe U7400 is bad. Well, I replaced it, still doing it, so that leads me to my next concern, is maybe the clock chip is no good, but I don't know. Is this our clock chip, or is... Yeah, that's our clock chip. This board has no liquid that I can see. I see thermal paste. Believe it or not, if this is Arctic Silver 5, this can cause it. But I don't think it is. So let's go over what quarter fan spin is. Wait a sec. Oh, you did not do that. No way. Okay. What is this? What is this, factory, or is someone trying to... And what is this? Oh, look at all this stuff near... okay, here's why we have quarter fan spin. It's simple as that. See this right here? See all of this? Okay, see how it's shiny and metallic? Maybe that tells you that it should not be on the CPU resistors or anything. Okay, maybe Arctic Silver 5 and some metallic compound, maybe you think that should not be in between resistors on the CPU. Come on. Okay, so this is almost like, this is... please, just... I don't have any words. This CPU is probably dead, so... Let's take it off. Let's clean it up, since now we know why it's not working. Okay, you cannot bridge metallic thermal compound, okay, on a chip that is going to need it. We could clean it, and this is going to work, but this will probably die. Well, maybe not. It's a sandy bridge. Okay, but that's why it's quarter fan spinning. I've seen it before. Okay, when you use Arctic Silver 5 or any kind of metallic thermal compound, and this is clearly Arctic Silver 5, okay, when it's shiny like this, or not even Arctic Silver 5, okay, this is why it's quarter fan spinning. Stop using this stuff on these boards. Stop using metallic thermal compound on these boards. It's going to spill over, it's going to get on these capacitors on the CPU, and it's going to die. So please stop that. So look at this. Okay, this is clear why it's quarter fan spinning. And the CPU is probably dead now. This is exactly why it's quarter fan spinning. Okay, and now I have to risk... Okay, I honestly, I have to have a talk with this customer about using this garbage on this. Never use metallic thermal compound on these. Well, Arctic Silver 5 isn't that bad, but I don't think this is Arctic Silver 5. One, Arctic Silver 5 is too thin. Okay, this is something else. This is a metallic-based thermal compound. This is made for desktop CPUs, not for laptops that have it's made for desktops that have capped CPUs, okay, that aren't, it's not going to hurt them. See, this is what happens. It spills over. Okay, what do you think? This is like running a wire across all this. This CPU is probably toast. I mean, it's probably what's probably gonna happen. It'll start and then it's gonna beep, or it's gonna hang, or it's gonna do something weird. But this is something I've been lenient about. You know, I used to say, oh, I just cleaned it, no worries, you don't, you know. But no, this is, I'm not going to charge full board repair rates for this, but I'm going to charge for, you know, fixing your problem. If you hand me something dead and I give it back to you working, okay, I'm going to charge you for it, you know. I may not charge you the full price for board repair, but I'm going to, you know. This is essentially shorting it to ground. I know a lot of you probably like Arctic Silver. Well, I don't think this is Arctic Silver. This is full-blown metallic stuff. And I don't know how many of else that were sent to me are like this now, and that's... Okay. Let's see if that did it. It's probably dead, but that's probably why we were quarter fan spinning. You work the devices, but yeah, it's simple as that. But this, and it's still quarter fan spinning. Yeah, you know, this is probably, the CPU probably died on this board. Okay, completely preventable. Let's see. This is actually where, see all this metal stuff? It's probably all under it too. This is a candidate for the ultrasonic, I think. But it would not surprise me. This chip is probably toast. It would not surprise me one bit if this chip is toast. I've seen it happen, I've heard of it happening, so just please stop with this. But it cools better than this. No, okay, it doesn't matter. It's gonna run hot. It's a MacBook. They wait till it's burning anyway. Stop using the metallic thermal paste. And here's another test I could test, see if the CPU is dead. So it has no V core, right? If I put my finger on this while it's pulsing, and if it gets hot on each pulse, I know this chip is shorted internally. Try that. I'm cleaning it a little bit better. Oh, it's all under the CPU too. Let's look at the FLIR. Let's get our FLIR and it's just stuff like this that kind of bothers me, especially from other technicians that, you know, please don't ultrasonic liquid damage stuff. You know, it's not gonna, you need to diagnose it first. You know, if you're gonna do anything, get a little flux, hot air, and clean the corrosion up with that. Don't just drop it in the ultrasonic. It sometimes can wreck them. So what I'm gonna measure is the CPU die temperature, and I do see a pulse on the FLIR, so that means it has voltage to the core, and that probably means that it's dead. So what I'm gonna do, since this has all this metal stuff all around it, let's have a look, see if I can see under the die. Yeah, it's got under there all right. Yeah, see it all under there? Alright, this is going to go in the ultrasonic. Let's hope for the best, but don't keep your hopes up. The chip is probably toast. It would not surprise me if this thing just died, you know? No, and it's not wrong to tell you, you know, sometimes you have to be to lead someone in the right direction. Some people might come across saying, well, you're being rude, you're you know, when I'm trying to help someone and, you know, help them learn. If I come across and tell you you're doing something wrong, listen, I'm not trying to be mean, I'm not trying to be rude, I'm trying to push you in the right direction. You know what I mean? So let's see what's next. This is a good one. No. If I come across and tell you, hey, stop doing this, you're doing it wrong, you're gonna ruin stuff if you're doing like this. I'm not being mean to you, I'm telling you, you know, I'm trying to help you, to lead you down the right direction. So, this is a 2879. And first thing, we're gonna plug it in, and we're gonna see what we get. We notice that we get, hey, did we? Got a little flash in the charger. Very dim light. Sometimes it helps to wiggle it a little bit. Okay, so we get no green light in the charger, get no power, nothing. So, what is the first rail we need to get a light in the charger? That is PP3V42. We're going to check PP3V42, and we're going to see what we get on PP3V42, and that's going to show up right over here. We get thing 1.18 volts. That is no good. Let's double check and make sure that I have the reading spot right. And where's open board view? What board is this again? It's a 2879, and PP3V42 shows up. I think what that is. Yeah, I was right. So 1.18 volts. Now a couple things are happening here. It's either being pulled down to ground by something, or the regulator is messed up. Now regulators can get messed up and send 7 volts to it. They can get messed up and not work at all. So we're going to measure in diode mode, see if we have a short. We have no short, so it tells me the regulator is most likely fine. I mean, there's no short, the regulator is most likely screwed up. So let's find where this comes from. It's going to come probably from U6090 right here, and needs a couple things to work. We're gonna have a look at that area, and it looks like it may have got a little liquid. So we're gonna check our inputs and see what we get, because in order for anything else to work, we need this power rail. Without this power rail, we get nothing. So let's check right here is pin 8. We should get, wait, we should get see, this is no good. We have half a volt on DC in. Now, if we have half volt on DC in, nothing's going to work. We need DC in power. So, what do we need for DC in? Let's have a look by the connector. Since we get no green light in the charger, what do we need? You look like you've been messed with. That does not look normal. And see that via right there? That fuse is fine. We're going to check. This is the first point in the system that we need to check, so we are going to check it. So let's measure what we have on DC in. Measure voltage on DC in. We're going to check both sides of the fuse. On one side we get 16 volts. On the other side we get 16 volts. We're going to check our U6900 right here. Of course it's not going to work because we don't have Okay, so here's something I'm going to teach you guys really cool, so this will help you as well. So, you guys probably can't see my multimeter, but I don't need a microscope, so you guys aren't going to be able to see it. There's no way you're going to be able to see it. So, PP3V42 is fluctuating, right? And what causes fluctuation? So, the people that are watching in chat, what is going to cause PP3V42 to go between 1 volt and 1.15 volt or 1.112 volts? What's going to cause that? And let's go over and look and see why that might be. Could be a number of things actually, but the schematic. First thing I need to check is our PP3V42 power supply. Oh, why isn't this going full screen? Whatever. I need my Adobe is being weird. It will not go full screen. It'll go like halfway. That's weird. Whatever. I'm gonna have to make. I'm looking at the wrong board too. Let's close Adobe Reader. It's being weird. So, hi Paul. 2879. Apple MacBooks. 2879. Alright, so we're going to look at DCN and we're going to try and restore our 3.42 volt rail so we can make everything work. So this is going to come in. Updates on radar projects. It's sitting outside right now, pointed up in the sky, and I could control it remotely when I want to and scan the skies. So Q7080 and Q7085, since we only have 1 point something volts on DC in. Alright, let's check on this. Right. We're going to check what we have on the MOSFET at the beginning and the end. So going into the MOSFET we have 16 volts. Coming out of the MOSFET we have 16 volts. That's good. Now R6905, which is up here. That looks suspicious, doesn't it? Let's measure one side. We get 2 volts. And the other side we get 16 volts. I wonder what's wrong with this. Let's see. What's the values that's supposed to be? So R6905, that tells me that's a problem right there. Or is there? Yeah, that tells me there's a major problem with R6905. Or, let's see, R6905, what is it? Is it 2.0K? I'm guessing that this is gonna read well over 2.0K. It's probably gonna read something in the milliohms, I'm sure. Yeah, it's 416K and now OL. Yeah, this is gone. So this resistor is bad, that's why we're not getting anything else, and it looks corroded in this area, so let's replace it. Actually, I have to pull out a schematic and find a resistor. Look at 2936, 820. 2936 should be right here. 2936. Let's get the ultrasonic. 69. No. She's looking for a 2.0K resistor. 2.0K. Yeah, so if you look right, well, you probably can't see, but R6905 is a supply for the 3.42 volt rail, and it is blown. So we have to find a replacement of this, and that's what I'm trying to do right now. R6929 looks a little different on the 2936, but it'll work. Back is bad today, I'm sorry to hear. D4 AM here, just stepping by to say hi. Let's see. What was that one component number again? R6929, 2936. 69, 29. Wait a sec, that's wrong. Yeah, I'm way wrong. That's not going to work at all. We're going to see how the circuit works on this other board, and we will improvise. Yes, it uses a different... Okay, well that's not good. Let's look at a... How's the stepper going? I haven't actually done it yet. Yeah, watts matter. That's why I'm going to try and find a better board. So let's look at a 2530. Let's see, 2530. This I'm saying might have it. Yep, let's see. R6905 on this one is a 47 ohm. Alright, so R6905. Huh? I'm confused. I confused myself. I thought it was a 2.0. I read the wrong schematic. It's a 1 ohm resistor. So that's why I couldn't find one. Okay, now I'm on the hunt for a resistor that will work. Let's try 2610 now. Or a, yeah, 2610 will work, I think. What's wrong with using the same type of resistor for each input? I don't get it. Maybe this one. $47 ohm. Come on, really? R6905, 5%. Here we go. Better just get one of the other ones. I can't believe there's not a suitable resistor on any of these. The difference is because of current limiting, and that's why. Alright. Let's try a, what else do I have here? Try a, you know what, 2936. I'm gonna improvise and use a different value resistor, so let's see, 6990, and we'll see what's the worst that happens, right? Alright, so this uses a 47 ohm. Okay, so an R6990. This is a newer board. This should work. So we're going to take it off of a 2936. 2936. Yeah, this will work. I don't see any reason why it wouldn't. I mean, it does the exact same thing. So you know, it should be fine. I don't see why it wouldn't if it does the exact same thing in the circuit. You know, now if I was going from higher to lower, I would be concerned. But if I'm going from lower to higher, I don't think it's a problem. We're gonna find out here very shortly. Let's get a 2936. Where does that resistor belong again? Oh, it's on this side. 70. I would have a fused resistor. That's not. I'm not too concerned. We're going from a higher resistance or lower resistance to higher, so let's test. So we get a green light in the charger, as you can see, and let's look at some nice fan spin here. So where's the power pads in this? Oh, I see them. See? Electronics engineering. Improvise. You don't need the same value resistors. You see it works. So thank you all for watching. I'm done, and have a good night. And don't use metallic thermal compound.